Good morning, students. For the fourth sem students, Pharmacognosy and Phytochemistry 1, which we have now today, we have taken the topic of evaluation of crude drugs, in which we have actually it's sometimes they used to ask essay question also and short notes also. So we should know about evaluation, some procedures. Some of them we will see in the lab also. At the time you will be understanding more. So I will give only some theoretical details. But some which are important, sometimes they are asking for 5-mark question like lycopodium method. We will have a discussion. So we will make it into 1 or 2 parts like organoleptic evaluation, microscopical evaluation, chemical evaluation and biological evaluation. So this chemical and biological, I have not much detail about each procedures, just giving some idea, because we cannot go far wider, because sometimes they will ask, we have many other chapters also. So anyhow, we will see in detail about the macroscopy, that means organoleptic characters, and macroscopic evaluation today in this session, and next session also. I will make it one session, so it will be easy for the students to listen instead of continuously finding difficult to listen the videos. So here in this chapter they have told us to cover this quality control of drugs of natural origin. Quality control, how you can maintain this quality control is very important, especially it's the main concept behind the WHO insist for herbal drugs and herbal formulations. The quality and as well as the safety and efficacy is also plays a major role for usage of any herbal formulation or herbal drugs. So quality control of drugs of natural origin is the major sector which we have to analyze the purity and the quality of the drug which you are using. Adulterations of the drug also can be identified. So they have given adulteration of drug of natural origin, which we have seen in the last class itself. And evaluation of organoleptic, microscopic, physical, chemical and biological methods. Also it should be included, which has been mentioned. So qualitative microscopy of the crude drug includes lycopodium spore method. They have mentioned specifically lycopodium spore method. That's why I have also given some importance to that particular method. And leaf constants like stomatal index, vein direct number, these all things by using camera lucida. Micrometers already you have come across in finding out the globule size in the physical pharmacy of other pharmacy subject, but still what is the use of this micrometer, stage micrometer and eyepiece micrometers, and calibration of eyepiece micrometer plays the major role to find out the size of the diameter or length of the fiber or diameter of the globules of or diameter of the starch grains can also be identified by this camera lucida, and also using stage micrometer and eyepiece micrometer calibration how to be done. So evaluation of crude drugs today, with you are talking about the introduction, just an introduction part. Suppose if it is an essay question, you should write drug evaluation may be defined as the determination of identity of any drug and the purity and the quality of the drug. So identity means identification of biological source of the drug, is also the authentication. Quality, the quality of the active constituents present in the constituents in the herbal drugs or formulation. And purity, the extent of foreign substances, because you see some of the times we cannot, unavoidable situation, there may be some dirts, there may be some debris which may be added or not added, it can be undeliberately, it may be in the part of the drug. So it's also they have given some limits. So the extent of how much extent of the foreign organic matters. That means the organic matter. For leaf means sometimes the stalks may be there. Flower means sometimes it also may contain the other parts, stem parts may be also undeliberately they may be present in them while collection, or maybe may not be removed. Difficulty will be there. So how extent it can be present also they have given in the limitations will be given in the various standard books which is governed like pharmacopoeias. They may give the limits, the extent of foreign organic matters or materials present in the crude drug. These all the purity, it also plays the purity. This is what we are going to see in the evaluation. So you can see evaluation of method, the drug evaluation method, in that the evaluation of the drug to drug done by study of various properties, like the various properties are organoleptic property, and the smell, color, flavor, and the taste. This all comes in the organoleptic character, and the and also macroscopy also even in the organoleptic property, macroscopic property, physical property. Suppose if it is a drug, there will be lot of ash values, extractive values, moisture content, and the melting point. These all are physical properties. Can also be many chemical properties. Chemical test, assays, determination of amount of constituents. These all chemical property. And biological property like pharmacological actions, and what is its biological activity by means of various antimicrobial activities which can be studied by microbiological study, tissue culture. These all, and also biotechnology. These all biological properties can also be studied for each and every crude drugs. So you see, this is about the evaluation methods. So by this we can categorize like organoleptic and morphological evaluation, microscopic evaluation or histological evaluation, physical method of evaluation, chemical methods of evaluation, biological methods of evaluation. Like that we can categorize. Very simple for the students to write what all the different types of evaluation. Evaluation of crude drugs, if anyone asks, then this is the important thing which the student have to explain about the basic thing. What is evaluation and how extend, what all the different types of evaluation can be performed for a given sample of crude drug, and how we can maintain the quality and the purity of the sample which is given. So first we will start about the organoleptic morphological evaluation. This refers to drug evaluation by means of our organs of sense, including the sensory organs like odor, color, taste and texture. So it includes the study of morphology and other sensory characters. So here the study of gross morphology, it includes the visual examination of the drug. These drugs are classified as following groups: barks, underground structures, leaves, flowers, fruits, seeds, herbs. All the organs can be differentiated by means of their morphological characters. Barks, simply I have given some examples to just have we will be studying in different chapters, especially regarding about the individual organ parts of the plants and animals. So drugs which is used, and it includes all tissues, woody stem, outside the interfascicular cambium. That means the bark is the outermost part of the stem which constitute to the drug. The bark are collected from the trunk, branches of the trees as a narrow strips. Example: cinnamon, cinchona, ashoka, kurchi. These all are barks which is used as a crude drugs. Medicinal purpose. During drying, the drugs may undergo unequal contractions and assumes different shapes. This is the example you can see. For example, cinnamon will be quill in form. Cinchona will be in the hard bark of the half size, you can see there. And you can see there are many other barks like Arjuna or Ashoka. They are differ by means of their drying techniques and drying temperature which is used, and the media which is used for drying changes the drugs in different shapes. which as shown in the picture. And next example, underground structures, many drugs, many crude drugs, many medicinal drugs, medicinal plant, the parts which is used, most of them, not, I'm not telling all, most of them, maximum, there are many. Rhizomes, roots, bulbs, corms also same, like underground structure like tubers are the underground structures of the plant which is used. They are swollen due to the storage of food materials like carbohydrates and other chemicals which is present in them. More carbohydrates, starch will be present in the rhizomes, underground parts of the plants like ginger, turmeric, jatamansi. Underground storage roots used as a drugs are ginger, example. There are many. Turmeric, jatamansi. It looks like a fiber, but it's an underground root, swollen, which is having more useful in many medicinal purpose. And leaves. So we are talking about the morphological type of classification, morphological type of evaluation, how the leaves are there. So by means of shape, whether the leaves alone is there, we can identify, just as examples I am giving. So leaf, the shape of the leaf, margin of the leaf, base, apex of the leaf, venation of the leaf can be seen. The purity of the leaves can be identified by means of these all these are the characters which is given by the original plant, original leaf. What is the type of margin, what is the type of apex, what is the type of venation, and this identification can be given for the drug, like senna leaves and examples, tulsi leaves. They are having different shapes and different, they are, suppose tulsi leaves oblong, but the sharp in the sharp and acute, the senna leaves. So there is a difference. So we can identify if there is any adulteration is there. Flowers, these are a reproductive organ of the plants and possess different shapes, size and color. Flora, like flowers, example also can be how many type, color is an example, saffron. We are taking the stigma alone. So saffron extracted from the flowers, used in the essence of the food. Saffron, you can see the stigma of the flower which is collected. So this is one example I am telling. These all are some of the important factors of morphological characters have to be identified for their quality. Evaluation of identification of fruits. Fruits arise from the ovary and containing seeds. They are globurous or globular, oblong and episodal in shape. So example of almond and amla I have taken, just to say almond is a seed, the fruit, and also amla. And seeds also, there is, we can identify what is the shape of the seeds. Seeds are developed from the ovules of the carpels of the flowers. They are characterized by hilum and microphyll, etc. can be given an identification of the seed like linseed and naxomica. We can see these seeds also can be identified for morphological character. And the next about the first morphology in the organoleptic character. Next comes, that is about the structure which we have discussed. Now the sensory characters. Study of sensory character, color, texture, odor, taste are useful in evaluation of drugs like color, odor, taste, texture. These all are the things which comes under the organoleptic evaluation. Color, some drugs are green in color and were dried in the shade, but they became pale and bleached when they are dried in sunlight. So Terminalia chabula, fresh and dried, it becomes change in the color. So this color also should be denoted whether it is properly dried or it is the original one or duplicate can be identified. Odor, the odor of the drug may be either distinct or indistinct. The term used for the drug as aromatic, balsamic, spicy, etc. So whether it has the proper volatile oil odor, then we can say that it is a pure and unpure drugs can be identified. Mentha, clove and some other are the examples of drugs which is having distinct odor and volatile principles which they are having. Usually they will have their own characteristic flavor. Taste, The drugs may be evaluated by the taste. The drugs may be evaluated by drugs taste also. There is also written by taste. The taste may be saline taste, sour taste, salty taste, sweet taste, bitter taste, alkaline taste, like that. Substance without taste are regarded as tasteless, and like ginger, capsicum, sometimes characteristic taste we cannot say, flavor characteristic taste there will be like saline, sour, salty, sweet, bitter, alkaline are tasteless, like ginger. And texture, sometimes the texture after breaking the dried one or the fresh one, you can see the fracture and the shape of the fracture textures. What is the texture while touching or while seeing? Sometimes the drugs can be examined by the consistency, texture and nature of the fracture. An example for colocin is an example just, but many other barks can be broken. There is fibrous, point and rough, like that we can say, rough polish. These all things comes, and the colocin is one of the compressed easily, since it is parenchyma is very loose, so the parenchyma is very loosely arranged, so it can be easily compressed. That is a plant. It's not a watermelon. It looks like the fruit like that one, but it is not watermelon. It is colocin. It is also having a parenchyma, loosely arranged parenchyma, so it can be easily packed and smooth arrangements can be seen. So that is about the fracture external character. Now we are coming to the microscopical anatomical evaluation. Microscopical anatomical evaluation. This is the second evaluation which we want to go for the study in this evaluation. If you see here, this method allows a more detailed examination of a drug, and it can be used to identify organized drugs by their known histological characters. So, TS, LS, which we might have studied, that before examination through a microscope, the materials must be suitably prepared. That we will be detailed, we will use to say in the lab. If it is a dried, hard one, soaked, and by means of using a new blade, take a thin section, watch glass with water, and select the section, and then go for preparation of the slide, preparation of the section for removing the debris by chloral hydrate or dilute HCl, and then we are going for staining by means of fluoroglucinol and HCl, and that will give the staining of lignin containing cells like xylem, phloem can be easily observed in your microscope. So this can be done by powdering, cutting into thin section of the drug by preparing and prepare a macerate by means of preparation. You can see there is a TS transverse section, longitudinal section, RLS radial longitudinal section. These all sections can be seen and the cells can be easily identified, and its presence of collenchyma, parenchyma, xylem, phloem, and how it can be stained by means of fluoroglucinol, and what are the cells which is given in the according to what is the type, what is the layers which is present, whether it is an original drug or it is an adulterated drug or it is not having the similar drug, it is a completely different drug, can be identified by the analytic, that is a anatomical characters or histological characters after taking the section of the given sample is also possible, and the powder microscopy also can be identified, and we can identify the difference. Microscope can also be used for quantitative evaluation of drugs of adulterated powder. So quantitative evaluation of adulterated powder, there are many things can be done. This done by counting the specific histological features such as stomatal number, stomatal index, and vein islet number, palisade ratio, quantitative microscopy, and determination of fiber length and width. And refractive index can be coming in the physical evaluation, but even refractive index also having abyss telescopic microscopic observation. So that's why we are adding here also, but it will comes in the physical evaluation. Refractive index of oils, fixed oils, can also be identified by the refraction. Refractive index gives the purity of the sample which is given, or the medicinal fixed oils can also be, or volatile oils can be identified by this method. The camera lucida, which I want to show, is there are two types of camera lucida in our lab and also everywhere, like mirror type and a prism type. Both are working in the same principle. Actually, they will reflect to the paper, black sheet paper which you have kept in the right hand side with a white pencil, where you can observe the object which you kept in the microscope. That is a compound microscope in the objective lens. Below the objective lens, how you are kept in the 45x. First you can select the 10x and then you can turn to 45x and see the stomata present in the palisade cells can be easily observed, and it will be reflected or it will be transmitted. Reflection comes by the mirror or by the prism to the right hand side of your pencil which you have kept there, which you should see. The calibration have to be done first. The square should be drawn in 1 millimeter area. How much stomata are there? How many palisade cells are there? It can be identified only by means of practice. When you come to that, how you can see that picture, the sir is keeping the prism type over the objective lens, and he did not show how to keep the black paper and the pencil in the right hand side, so that it will be the object, the light reflected there, and so you can have a stage micrometer which you can keep, and according to the magnification 1 millimeter. Actually 1 millimeter, the transmitter, that is square 1 millimeter, you have to 0.1 millimeter have to draw in the square in the black sheet, and inside which how many palisade cells and how many stomatal index or how many vein islet numbers can be easily drawn, and then you can calculate and the index can be made for the purpose. So this is about the I told the stage micrometer and eyepiece micrometer. We can see in the lab very clearly. So these are the calibration. So when you want to draw something, when you want to observe something in the microscope, the calibration plays a major role for you to identify. So calibration, you see there is the picture which shows the first one is eyepiece. In the eyepiece you are keeping two types of eyepieces are there. So you might have come across, the pharmacy students might have come across this eyepiece, especially in your globule size in your physical pharmacy, to identify in the emulsion the globule sizes can be, or the size of the powder, coarse powder can be identified by means of this, preparing a slurry or preparing a solution or a semi-solid mixture with a fluid, and keeping in the slide and focusing, you can find out what is the size of the, that is diameter or the size of the globules can be identified. The same system we can use for size of the and also drawing one square and drawing, that is camera lucida is different, but apart from that, size of the starch size, fiber length, width of the fiber length can be identified, but calibration plays a major role. So what is calibration? You have to calibrate your eyepiece by using the stage micrometer. See, stage micrometer, you can see it is 1 division is equal to 0.01 mm. That means 1 millimeter is divided into 100 division. So 1 division is equal to 0.1 millimeter. That is what here it is. There will be a slide, a stage micrometer, which we cannot see by means of only one round will be seen. But when you focus in 10x or in 45x also it is possible. Whichever microscope which you are going to use, that in that you have to do the calibration. That is very important, because the observation, first you have to observe in the 10x, and if you are going for 45x, you have to turn it 45x and see the coincidence, the stage micrometer and the eyepiece micrometer. So only thing is very simple for the student. You should not make it as like how you studied vernier caliper, how you studied the screw gauge. These all having a least count. So what is the least count? That means least count. What is the coincidence? For example, you are calibrating one division of eyepiece or the square which I shown here. There is many. The square which I shown is sometimes globules are there, means you can see very easily how many square is occupying my globules that can be identified. So 1 square is equal to how many divisions of my stage micrometer, because stage micrometer is known measure. You know that 1 division is equal to 0.01 millimeter, or micrometer, you can say it is a micron. So you can see 1000 micron is equal to 1 millimeter. So when you are dividing into 100 divisions of 1 millimeter is coming to a 0.01 millimeter. That means it is of 10 micron or 10 micrometer. You can say 10 micrometer. 10 micrometer is equal to 0.01 millimeter. So it is easy for you to calculate how much micron. If it is 1 division, then you can say it is 10 micron or 10 micrometer. Understand? 10 micrometer. So you know that 100 micrometer is equal to 1 millimeter. 100 millimeter is equal to 1 meter. So that is a simple calculation which we know. So by that, you know there is a line which is already prescribed by the stage micrometer. So in that 1 division of my stage micrometer, how many division of my eyepiece? This is what your calculation. Once you finished, take the stage micrometer and then see your object keep in the objective in the eyepiece of the compound microscope and count how many divisions are occupied my object. If it is 2 division, 1 division is equal to 0.01, 2 division means into 2 it is 0.02, that means 20 micron, 3 means 30 micron. So very simple. This is, I am making it very simple before calculation. Every student should know that. Calibration means, just for example, if you keep an 10x in the eyepiece, or in the objective if you keep 10x or 45x, the magnification will differ. Am I right? So in your 10x, when you see 2 divisions are equal to 1 division of your stage micrometer, but in the 10x, if it is 45x, the magnification will be very large. So you can find that it's only 1 division, even 4. Understand? You can see that 4 divisions of my eyepiece is equal to 1 division of the stage micrometer, because it is magnified. Understand? So like that, there will be a difference. It can be identified and it has to be calculated. So here, this is again I have shown, this is when you are seeing how they have divided 1 millimeter into 100 divisions, will be very, very small lines can be seen in the stage. 1 stage micrometer, 1 millimeter long scale, 1 millimeter long scale it is, with 10 micrometer division, and it is labeled and 0.1 millimeter, every 0.1 millimeter. And you can see this is the eyepiece micrometer scale, and this is stage micron, and you can see that is eyepiece 100 divisions. They have seen 100 divisions are equal to they are coinciding. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divisions of stage micrometer is equal to 100 division of eyepiece. This is an example by the magnification he is seeing. And then you can say 1 division of eyepiece stage micrometer is equal to 10 division of eyepiece. So suppose an object is taking 10 divisions in your eyepiece, because stage you will remove after calibration, 10 division, you can say okay, it is 1 division of a stage micrometer. So it is 0.01 millimeter. Understand? So you can take 10 or 20 average and divide, and you can say this is the size of globules. Very simple experiment. Understand? Our length, width can be easily calculated. So suppose that the stage micrometer scale has a division that are equal to 0.1 millimeter, which is 10 micrometer. Suppose that the scale of the line up to ocular, that means eyepiece, and 100x you are observed, the each micrometer device covers 10 ocular division. So there is difference according to the eye, that is the objective lens which you are using. So then one ocular division is the smallest 10 micron at 100 power. The conversion of magnification is accomplished by factorizing the difference in the magnification. So what is the use? For example, the calibration of 25 micron at 40x in the objective lens, 2.5 micron at 400x, and 1 micron at the 1000x. So this is some example. When you are increasing the magnification, automatically you will have the value changes and the calibration can be done. This is just to make the coincidence. As I told you, should remember the main concept behind for the experiment conducting the students or the scholar or whatever the researcher, your aim is your eyepiece divisions. How many division is equal to my stage micrometer? Because stage micrometer is a known value, is a standard value which you got in the slide. So that's why I showed the picture also. You just see the previous picture. Which one is not this one? This one. This is eyepiece. This is stage micrometer. The stage micrometer is a value which is recorded and a scrap which is lined, and it is the thing which is standard. And for that you are calibrating your eyepiece. Eyepiece may be vary. Eyepiece may be where that number is not specifically not 1 centimeter or 1 millimeter like that. They just make lines, and lines in the divisions, according to the divisions, how many divisions is equal to the stage micrometer you can calibrate. So that according to your power or the objective lens magnification, it will change. The divisions may change the value by calculation. So stomatal number, the average number of stomata present per square millimeter of epidermis is known as stomatal number. Stomatal number is relatively a constant for a particular species. About one species will have this number, so this is a standard value will be given. So by that you can find out whether it is an adulterated one or a pure one, or the original drug, the particular species, the same age, and hence it taken its consideration as a diagnostic character for identification of leaf drug. Example, Datura 141 upper epidermis. So stomatal numbers, we can draw it in a black paper by means of using camera lucida, and you can find out how many numbers of stomatas are present. And you may be knowing about what is type of stomata also, where is parasitic, anemocytic. This is about, you can see that is anemocytic type of stomata which is present in the Datura stomanium. And next one is stomatal index. Stomatal index means you can see it is the percentage proportion of the number of stomata to the total number of epidermal cells. It is the percentage proportion of the number of stomata to the total number of epidermal cells. So stomatal number varies considerably with the age of the leaf, but the stomatal index is relatively constant for given species. So that is very important. Stomatal of Atropa, you can see 20 to 23 lower epidermis. So stomatal number varies considerably with the age of the leaf, but stomatal index is relatively constant for the given species. So stomatal index can be identified. For example, stomatal index means total number of stomata in the unit area, that is 1 centimeter or 1 millimeter square area where the black sheets which you are calculating, and number of stomata per unit area plus number of stomata, epidermal cells also you should compare unit area, which area you have taken. So epidermal cells plus the number of stomata per unit area, the total number of stomatal per unit area in the top into 100. You can get the stomatal index, which is constant for a species. And vein islet number, veins. Veins are prompt in certain plants, certain leaves. So it can also vein islets. You can say islets. The 1, 2, 3, 4, 5. There are islets. The bigger outside the square which you have drawn also we can count, because half only little has gone, but completely if it is outside, then you cannot count that islet. But you can see the terms vein islet is used for the minute area of photosynthetic tissue encircled by ultimate division of the conducting strands. Vein islet number is defined as the number of vein islet per square millimeter of leaf surface. It is constant for given species of plant and it is irrespective to the age factor. Example, Cassia senna 26 islet usually will be present. And then palisade ratio. Palisade cells in ratio, palisade cells, it is represents average number of palisade cells beneath the epidermal cells. The cuticle epidermal cells, you can see this picture, epidermal cells and below palisade cells this is numbered. And palisade cells beneath one epidermal cells using 4 constituent epidermal cells for count. So it is determined from the powder drug with the help of camera lucida. Example, Atropa belladonna 6 to 10. So this is also a quantitative estimation of the microscopy, quantitative microscopy. This is a quantitative microscopy pharmacology picture, just taken an example to show you vein islet number 27 is seen in the senna leaf, and here 22, and in one ratio you can see 1:7 palisade ratio and palisade ratio in 1:9, like that palisade cells ratio picture and the vein islet picture directly I have just shown to show you how they will find out these ratios, quantitative microscopy. And quantitative microscopy, that another one very important aspect is how to be discussed in this area. So anyhow, this is I made it very lengthy, so the students may not we need some gap and then we will start. So I feel up to now, and next let me continue with the break and let me continue with another class. Thank you. So this is part 1 and part 2 for evaluation. Like that I am just going to continue. Thank you.